Hey, how's it going, guys? Daniel here, aka HashLips, and welcome back. And we are continuing with our game creation. If you've made it this far, congratulations. It means that you are actually starting to understand a little bit about blockchain. I hope so. But anyway, let's carry on and finish the smart contract, well, the first version of it. Now, the first thing that we want to do is actually get rid of this 1 in the counter because we want it to initialize to 0. And we don't need to tell it to go to 0 because by default, the variables initialize to 0, especially for an integer. Now, the next thing we need is some kind of way to mint an object. And when I say that is because we don't want to just mint IDs. Our game needs something a bit more tangible. And I'll show you what I mean in a second. We get a data type called struct. Now, a struct is something like an object that can be defined. And you can use it as a little blueprint to define more of these objects. How you declare it is you say struct. You give it a name, and we'll just call it lip, because we are defining a lip, seeing that we're going to make a bunch of them. And next, what you want to do is actually define the properties that your lip blueprint should have. The first property I think we should have is a string, which is going to be the name, right? We just can do just name. You have to define the data types like this. So the next thing that we also need will be a uint 256, the ID, and then another uint for the DNA. And let me quickly just stop here. For the ID field, we need this, even though we are going to have access to the array that we're going to put these objects in, the index, which is going to be exactly the same as the ID, but we need it here for easy access, right? And then the DNA is very important. This, at the end of the day, would be a randomly generated ID. Well, not ID, but a long digit number, 16 digits or 14 digits, that we can use to generate the actual images of the lips in the game. And that's going to be something cool that I can go through with you guys. Next, let's give it something else, right? So let's not make it too complex, but actually let's give it something cool, at least a bit cool, right? So we're going to add a level. And this doesn't need to be 256. We can make this uint 8 because this only has to go up to 255. So we'll call it level. And also, when you declare your variables, it's very important to kind of take in consideration the size that these variables in memory keep, because the more you put on your smart contract, the more it costs to deploy, and also the more it costs sometimes in your functions to run, because people have to pay gas fees to run certain functions that's bigger and smaller. So, but that's for another day's tutorial. So we can also have maybe another uint 8 of rarity. Let's do a rarity. And I think that's about it for now. We don't have to make it too complex, but basically we've defined a blueprint for how a lip should look. Now, next what we need is actually a type of data structure that's going to hold a bunch of lips. And it's very convenient. You can create a structural, like a struct, right? Array. So you define it by defining your struct name with these brackets. This will actually tell Solidity this should be an array of lips. And you can just do it like that. Now we're going to make this public, so we have some oversight over it outside as well. But generally you'll make this private or internal. Okay, now the next thing what we need to actually have a look at is we need to relook at our mint function. Because currently we're saying that this should be public and it should only be the owner, which doesn't really make sense because we're not going to mint these NFTs ourselves. We want people to actually mint their NFTs by themselves. But a nice way and structure to do this is first to create an internal function, something that is not accessible from the outside, that handles the inside processes, if I can put it like that. So just change this function to internal. Internal means that only this contract has access to this, right? Internal, well, this contract and other contracts that inherit from it will have access to this. Private only this contract will have access to it. So we're going to make it internal. And the convention for naming internal functions, you add an underscore in front of the name. Now let's give it a bit of a better name as well. Let's call this create lip. I think this is much better. And create lip is now going to take different parameters. First thing, we're going to have the name of the lip that we want to create, and we want to supply it with DNA. Now, we know that name should be a string, so we're going to say string, and we're going to just quickly say name. I'm going to pause and come back to this now. After this, we also need a uint 256 because we're going to need a DNA, and the DNA is 256. That's why we make it uint 256, so it's compatible. The name, you'll see, will give us an error, and the reason for that is you have to say memory in front of it, just like we've done here with the constructor. All right. Next, what do we need to do? So let's get rid of all these. Well, we don't have to get rid of it for now. We can just comment it out, and we will uncomment it when we're ready to use it again. So the first thing that we actually want to do is we want to create a new lip. Okay, so this is just our blueprint, but how do we create a new lip? Well, you do it like this. You say lip, which is the data type, which is our struct, and then you go and say memory. Now this is the same as string, and remember I said that arrays, strings, structs, those things get memory in front of it. It's a bit of a hassle to understand this very good, but basically you get memory and storage. Storage is when you actually use the variables inside the smart contract. Memory is on the fly memory that will be removed after you've used it. So you'll get more and more used to this as you work with smart contracts, and I'll go into depth in this in a later tutorial. But for now, just put that there. Now what we want to do next is give it a name, and we're going to call this new lip. I think that is a fitting name, and we're going to equal it to some value. Now we want to actually create this lip, and the syntax for that is you say lip, you put your brackets, and then in here it's almost like you're calling a function. So in here you actually have to define these fields. Now where would we get the name from? We get it from our parameter. So this is where we can actually say name, and you actually have to go in the order that these things are in. So next we need an ID. So where do we get an ID from? Now remember we have our counter, and before we also used our counter in the mint. This is where we're actually going to get our ID from. So you can put the counter in next. After that we need the DNA. So DNA will be passed through to this function, which will be generated on another function before we call it. So we will have the DNA, but we have to put it in there because we're going to instantiate the object. Next, we need a level. And I think for now we can just say every lip starts with level 1. After that, we have the rarity. Now, we don't have some mechanism to do rarities yet, but I think a good, before we get to the rarities, we'll just instantiate that as a level 1 or a rarity 1. Maybe we'll make the rarities out of 100 and we can go up to 99 or 100. So let's make it 1 or 50. Let's say 50. This will be half rare, whatever you want to call it. So we can save this, and let's just add some spaces in here just to keep it a bit nicer. And this will actually create the lip and save it in memory as a new lip. Now what do we actually want to do now? Now the next thing that we want to do is we actually want to add this lip to our array. And you can see that it consists of lips, a lips array. So we can use this new lip. And how you would do this is you can just say lips, which is our name, okay, lips.push. Now lips.push actually also is in JavaScript. It just basically adds the lip onto the array. So we can say, well, push the new lip and be happy with it. Okay. And now this mint function has basically created a lip. We have pushed it to the array. So now we're happy that we've saved our game object. We also need to mint it now because now we actually want to mint this token and put it on the user's address. We don't take in the address with this function. Instead, we want it to mint to the sender's address. And how do we get that? We can say message.sender. Okay, message.sender actually is the address of the person who initialized the transaction, right? So we can get it from there. So it will mint to the guy who kicked off this transaction, and then we need to pass the token counter. So it's the same counter that we've given for the ID, and also think about it, because the array has a 0 index, this first element will also be 0, so everything fits nicely. The last thing that we want to do, second last thing, is we actually want to increase the count. Now this is all perfectly fine and will work like a charm. I just quickly want to jump off to the ERC 721 contract and just show you guys something that contracts do. And let's look at this mint function. So when we use the mint function, it actually takes in the address and the token ID, and it does a bunch of require statements, checking that the address shouldn't be 0 and exist, the token doesn't exist, and all these things. These are the smart contracts checks. But right here at the bottom, we get an emit. And an emit is basically emitting an event. And so after each mint, it emits a transfer event. Now, events are very, very nice. How can I say, structures to put in place in your smart contracts, because when you mint something, you don't really get a lot of feedback. You get a lot of feedback about the transaction kicking off and everything happy and working, but we want something to be returned to the front saying, well, something has happened on the blockchain now. Here is what has happened, and here's some values about it. So you can actually track these events throughout your app. We don't have to add it right now, but I think if we add it, if we add it now, then actually you get to see how it works, because we are going to be adding a lot more later on. So let's, underneath this array, create an event. How you create an event is you say event, you give it a event name, and in this time, well, in this case, for this function, we need to kind of say new lip, because that's what this event will emit. Every time a new lip is created, we will emit this event. Now you do it like this with the braces again. With the brackets. Then what you can do is put in your variables, much like this, but this time we're going to do it with the commas separating them. The first thing that we need is an address. Okay, so the type is going to be an address, and it's going to, for the name, we're just going to say, well, this is for the owner. And then, comma, we're also going to need maybe the ID that was minted. And then lastly, I also would like to know the DNA of the lip. So when a new lip is created, I would like to know who got the lip, what was the ID, and how does it look in layman's terms. Now, in order to search through the addresses on a later stage, when we're using the front and you really want to use the events and you want to subscribe to them, you can make these variables indexed. So we're just going to actually make the first one indexed. It just means that we can search through this field on a later stage. Okay, perfect. So now next what we want to do is we want to emit the new lip. So right after we've incremented the counter, we can now just simply say emit new lip, like so. And then what we need to do is just pass it the values. Now we can see again, we need an address. Now we can just take the message.sender for the address, because it's going to be the same. And then we need the ID, and we need the DNA. So this is easy, right? So we can use the counter for the ID. Well, we can't use the counter for the ID. Let's think about this quickly, because this is now going to be incremented. So, and I like to emit events last. maybe this won't be a problem if we just move this below. I don't think it will be a problem because I don't want to increment the counter yet. Okay, and then lastly what we need is the DNA, which was passed through the function at the top. And let's just see if this will work and if everything was still fine and happy. So how can we test this smart contract now? And I mean, we're pretty far because now we got a lip, we have an array of lips, and we actually have you know, this code that actually creates it. So what we can also do before we run this program is let's create a way for us to retrieve the lip array. Okay, I'm gonna create a function and let's do it below the creation of the lip. Let's say function, and what are we gonna call this function? Maybe lips or get lips. Yeah, let's do get lips. All right, so get lips is going to be a function, and it's not going to take anything. It's basically going to be just a public function, and we are just going to return lips. Now, when your function returns something, you actually have to tell it what it is going to return. So you have to add the returns, and then you pass it in what it's going to return here. So we want to actually return the lip array. So I'm going to say that we want to return a lip array. Okay, simple like that. So once we have this, we can now go and we can say, well, now we need to return the lips. So we can just say return lips, like so. And okay, that error is gone. What is happening here? Okay, data location must be memory or callback. So we need to say, well, this is going to be a memory lips that it returns, or callback, whatever, but then it will work. Now it is giving us this, and the reason why this is giving us a warning is because we can now make this a view function. A view function basically just says, yes, make this public, make this accessible to the outside world, but we are not changing anything in the smart contract. We're just returning something like a value. It's a call function. So we can just call it a view, and that just makes the compiler happy, but also informs us as developers that this is not changing the blockchain. Okay, cool. So now we need a way to actually call this createLip function from the outside. So obviously we will need a function that's public that the user can call. But before we get to that, let's just organize the code a little bit, because it's getting to the point where we need to organize it a little bit better. So I'm just going to move the constructor up here, leave the variables there, then these functions down here, I'm just going to comment it out and say, well, not comment it out, but leave a comment. There is a nice way of doing this. So we're just going to say this is the creation, and then this is the maybe the getters, because we're going to get stuff there. And then now we actually have a nice place to put this function. So the function that we need is going to be something where we actually need to get the, well, create the lip, right? So we can maybe call it create random lip. What this function is going to be is public. So let's make it public off the bat. And we're going to have a string. So string memory, and we're going to give it a name. So we can actually use this name to create the random DNA that we need. But a nice step to follow is actually call the function, put it there, and see what parameters it needs now. So this needs a name. So we're going to give it the name that's being passed in from this function. And then we need the DNA, right? So we don't have the DNA yet, so I'm not going to put it there, but let's just maybe leave it blank for now. But we need some number in there, and specifically we need the number to be kind of a 16-digit number. So let's think about this. Okay, so now we need to create a section which will be helpers. We're going to create a function, and here we can just call this function maybe a gen DNA, I don't know, generate DNA, right? So let's do this, and actually let's just add random, because this is going to be random. What this needs to take in is a string, because we got this name variable over there which we can pass into it. So memory, and we're going to call this not name but just string or str. Okay, so this is going to take our string and we're going to manipulate this, but it's also going to return to us something. So we can make this internal because the smart contract is going to be the only thing that uses this. We can also call it a pure function. Now pure we haven't talked about, but it's it's very similar to view, whereas view returns something in the smart contract. It needs to actually make use of smart contract values. If a function doesn't make use of any variables in the smart contract, it's considered to be a pure function. We can say that this thing returns a uint 256. We can open the brackets, and then simply what we want to do is we want to say that we need a uint, and this is going to be our random number, right? Let's just say this is the random num, and then what? We actually want to equal it. So there is a thing in Solidity and smart contracts that you can't really create safe random numbers. And when I say that, it's because random numbers and randomness works with can be manipulated by the miners on the blockchain. So when you do this kind of method, make sure that you don't use this for very secure things. Also, there's much better ways of doing it outside the blockchain and then bringing it in, but that's for another day. For now, we're just going to write this simple algorithmic thing that will give us a random number. And what we do is we actually want to start off by casting a uint 256. We're going to make use of the Keccak 256 hashing algorithm, which will then return to us integer, right? So a big number of integers. And we're going to use the ABI dot encode it, or encode pack. Okay, encode packed, and then we're going to pass the string. So okay, we're going to pass that. So basically what this does is it's going to take the string that we're going to be inputting into this function. It's going to make sure that this can hash the string properly into a number. And that's basically what it does. And to make sure that our number is going to be 16 digits, we can use modulus. Now modulus works like this. You can say 4 modulus 2 is 0, or 4 modulus 3 is 1. And why is that? Because 2 goes into 4 2 times exactly, so there's 0 remaining. And also 3 goes into 4 one time, but there's 1 remaining. So modulus is basically the remainder after it's been divided into the number. So that means that if we say that we want to return the uint, well, we can just return the random number, but at this time we're going to use the modulus symbol, which is that percentage sign, and we're going to modulus it. So if we say that we want to modulus this big number, and we give it 1 with literally 16 zeros, okay, this is going to give us a number that is 16 digits long. But there's an easier way to write this, and that's to say to the power of 16, and that's it. And we return this, and everything is happy. Okay, so this function now will return to us a 16-digit number. So what we can actually then do is implement it here at the bottom. Okay, so before we actually create the lib, we want to do a short random number. So we can say rand DNA. Okay, and then once we have this, we can actually call the generate random DNA, and we pass it in a string, which will in this case pass in the name that we have here. This in turn will return a DNA in there, and also then we can pass it here. Now because this is public, we have access to it from the outside. which means, ladies and gentlemen, we're going to be building our smart contract and testing it out right now. So make sure you've got your lip token selected. Okay, and then to deploy it, I'm just going to clean the previous ones. To deploy this, I'm actually going to just call it lips token and comma. We're going to say the symbol is going to be lips, and we're going to say deploy. This has ran successfully. There you can see it at the bottom. Just want to move this up a little bit, but there it is, and there's our smart contract. So if you open it, again, we see all the functions like we have before, and also the call functions. But this time we have extra ones, right? We have this get lips and the lips and everything that I showed before, but we also have now our create random lip somewhere. So let's search for it. There it is. Okay, create random lip, and that's public. So now technically how this should work, and remember, anyone can call this function now as long as you connect it to the blockchain and you can call this function and you're passing it in a string. It will take that string and create this random DNA, and with that call create lip, passing in the name and the DNA. So let's call this lip. I'll call it Daniel, and let's see what happens. So it says created. Now, how do we know it's created the lip? I mean, we can look through the logs and we can see a bunch of stuff. So let's just open this for a brief second, just so I can show you something. When you go through the transaction now, and remember in our create lip function, we are emitting a new lip event. So if you go down and you look in the logs, somewhere here in the logs, there we go, event, new lip, and there we can see the ID, the address, well, sorry, not the ID, this is 0, so that's the address, that's the ID, and what did we say? This is the DNA. So that's the DNA. And that's pretty cool. I mean, there's our log, and that alone will tell us that it worked. But there's more ways of checking this. So what we can do is we can, because we know that that ID should be ID 0, we can say, well, 0, go and query our array, right, which is this array, and see if it's in there. And when we do, we actually get back our full struct that we created. We get Daniel, which is the name of the hash lip. We get its ID, which is 0. We get the DNA, which we'll use to actually create the image at a later stage. We get the level and the rarity. And that is pretty freaking awesome. We can see a bunch of other stuff like I've shown before. We can say who's the owner of the ID 01, and you can see that it's this address. Okay, and this will be the address that we are using over there. Now, that is pretty cool. We can also create a new one. Maybe we call it, I don't know, Yoda. And once we've created Yoda, you know, if we query 0, it's still Daniel because that's on ID 0. But if you look at ID 1, you can see there's Yoda. Okay, so ID 0 is Daniel, and then 1 is Yoda. 2 won't exist, so if you call it, it won't change. You will see if you call it at the bottom, it fails because there is no ID 2 yet. But basically, that's how it works. And we can say get lips. Remember this function that we've created here at the bottom, and this returns to us a whole array. And there you can see there's the array, and there's the first lip up until this line, Daniel, and with all the values, and then Yoda with all the values. So that's just a nice way for us to retrieve the lips in the game, to work with them and display them to the user. All right, so I think that is pretty cool. I just want to lastly, before I end this video, show something quite cool. So when you go and say what's the balance of an owner, right, it needs an address. So if we go and we copy this address that we are working with now currently, and we go to the balance of call, and we just paste it in there immediately, what we can see is that there's a 2. Now, this means that this owner of this address owns 2 NFTs, basically. we can do another one, and let's just call it, I don't know, blocker, whatever. But we can create another one, and when we create this again, you can see this owner has 3. Now, what I wanted to show is that this is truly a ERC 721, because now let's go and select this contract's address. We'll select it. We'll go back there, and we will paste this in there. So we will actually say paste that address, and we can see that there's 0. We're going to make sure that we are on the first address again, because that's the address that has any tokens. And we can say we can actually transfer these now. So you can see that there's a transfer from, a safe transfer from, whatever you want to do. But we have a bunch of options, right? We can just say transfer from, or safe transfer from. I don't know what the difference is really, but I mean, obviously safe transfer from is more safer. I think it verifies that the other account has actually received it. But let's use it, and let's see how we can actually transfer the NFT. So I've got way too many things open here. I'm just going to close them, otherwise we can't see what I'm doing. Safe transfer, there we go. We want to transfer to this address that we've copied. We want to transfer Yoda, which was ID 1, I believe. And we want to actually do it from our account. So we want to do it from our accounts. Okay? And when we do that, you can see, boom, it worked. So now, if we query the balance, you can see that the owner has Yoda, because that is ID 1, right? And he didn't have a NFT before. His count was 0, but now he has. And if we look again at our address, we only have 2 now, and we used to have 3. So there, the transfer function works of the NFT. So that's pretty cool. It's showing up, and you guys have done so well so far. So I hope you guys are still enjoying this tutorial. What we'll be doing next is implementing a bit of more game logic functionality, just to make sure we have some kind of thing running here. And then we'll move over to Truffle, Ganache, and set up a React.js project so that we can actually start rendering things on the blockchain, well, from the blockchain onto the browser, and start our game.